Hey there, hi, and hello. It is Mr. Biggers here, and I want to teach you how to do some more advanced problems with surface area. This is Module 11, Lesson 4. This is day 1, but this is going to help you with today and tomorrow's assignments. First things first, I went ahead and pasted our surface area and volume formulas. We're going to come back to these for the remainder of everything. So the one new definition we're learning today is called lateral area. So what is lateral area? So lateral to me sounds like the word ladder. And when I think of a ladder, you know, it gets you from high to low. So lateral area is literally the area of the space from the top of a figure to the bottom of a figure. So like this white shaded area on the cylinder is the lateral area. Same with the cone. The white shaded area is the lateral area. So really what you need to do is remove the area of the base from the surface area to get the lateral area. So we're going to try it here with this cone. So how do you find the surface area of a cone? Well, we can see the surface area of the cone is found by taking pi r times the slant height plus pi r squared. Okay, so we are going to find the lateral area of that. So the surface area, let's go ahead and do it. So you can see here, I do not have the radius nor the slant height, so we have to figure out the slant height. So the radius is going to be half of that 14. So I know the radius is equal to 7 millimeters. So we can use that 7 and the 24 to make a right triangle to help us find what is that lateral, or sorry, the slant height. Okay, so remember I have 7 at the bottom, 24 on the side. So I'm going to really quick do some Pythagorean theorem math. So 24 squared plus 7 squared is equal to that squared. So we'll get 25 is the slant height. Okay. So make sure you know how to do that. You're going to need that in a couple of the problems. So now I can go ahead and plug everything into the formula. So it's going to be 3.14 times the radius, which is 7, times the lateral height, which is 25, plus pi r squared. So 3.14 times 7 squared. I can type all of this into the calculator. So 3.14 times 7 times 25. And I get 1032.6204. The one thing you have to do is remove the area of the base. So how do you find the area of a circle? You are going to have to do pi r squared. So you can minus that 3.14 times 7 squared. Okay, so I'm going to do that, minus 3.14 times 7 squared. And you get 878.7604. But we're going to say 76. So this is the lateral area of that cone. I know it seems kind of intense. It can be. So make sure you follow through and listen to the words that I said to explain that process to you. Also, if you notice in the formula, we are just adding the area of the circle. So this here in the formula is the lateral area of a cone. So it's pretty easy to just kind of get rid of that. It's going to be the same thing for a cylinder too, okay? So the lateral area and surface area of each solid, you can pause the video at this point and work these out, see if you can figure them out. So I'm going to go ahead and do this. So lateral area of this shape here is, remember, going to be just those that are on the side. The top and the bottoms are not a part of this, so we need to exclude those two. So all I'm going to do is find the lateral area. So I've got 10 times 12, and there's 2 of those faces. So 10 times 12 times 2 is 240. So that takes care of this side and this side. So now I just need the front face here and the back face, which we know are the same size in a rectangle. So that one is going to be 12 by 12. And then there's 2 of those faces, so I need to multiply it by 2 as well. So the lateral area of those is going to be 288 plus 240, which is 528 square yards. Okay? Now, if we remember our life hack from the cone, the lateral area of the cone is just pi r times the slant height. Okay? Because remember, we ended up, see what I'm circling now, we ended up just subtracting the area of that circle. So to find the lateral area of the cone, we just do that. And I'm going to scratch out surface area because that's doing too much. So that's how you would find the lateral area. How I would type this in is 3.14 times the radius, which is 5. And the slant height, you have to do Pythagorean theorem very quickly here with that right triangle to figure out what is your slant height. So if you do that math really quickly, your slant height is going to be that's your slant height, 14.866. Okay? And this one is going to be similar to the way number 1 was done. But to just save time, I'm going to skip on to the next. So find the surface area of a cylinder with a height of 7 feet and a base diameter of 4 feet. So we're going to use the formula for surface area for this one. I'm going to skip that because that's a pretty basic problem, but I do want to go ahead and write down the formula for you for the surface area of a cylinder. It is this one here. Okay, so I'm going to go ahead and copy and paste that onto the notes for us so we have it. Surface area of a cylinder. So we're going to hit done, copy and delete. I'm going to hop over here to the back side. And that's the formula you're going to want to use. Okay. So this one's a more applied example. A company made a storage container with sheet steel walls. The container was shown in the shape of a rectangular prism, as shown below. Suppose the total cost of the sheet was $7,590. How much did the sheet cost per square meter? So first things first, we have to figure out what the surface area of the figure is. So to find the surface area of this figure, you have to do the formula for surface area for a rectangular prism. So I'm going to find the the perimeter of the base times the height plus 2 times the area of the base. So the perimeter of the base is going to be 6 plus 6 plus 7 plus 7. So 26. So that's the perimeter of the base times the height of the figure here, which is 5, plus 2 times the area of the base. So the area is 6 times 7, which we know is 42. And then that's my height, 5. So that's going to give us the surface area of this box. So that's 214 square meters. So if they spent a total of this, we have to divide the amount of money that they spent by the amount of square meters that we have to figure out what is the cost per 1 square meter. So 1 square meter is going to cost us, let's see, 214, $35, and you round it to the nearest dollar. So it's 47 cents. So 1 square meter of this material that they're using costs $35.47. Okay? This is the other type of example you're going to need. The sphere is easy. Just use the formula, okay? But I do want to make sure we touch on this really quick. So a company manufactures aluminum mailboxes in the shape of a box with a half-cylinder top. The company will make 1,572 mailboxes this week. If each mailbox has dimensions as shown in the figure below, how many square meters of aluminum will be needed to make these mailboxes? In your calculations, use the value of 3.14 for it and round your answer up to the next square meter. So you're going to have to find the surface area of the rectangle or the box plus the surface area of 1/2 of the cylinder. So you're going to have to take half of the surface area of the cylinder, okay? So this is going to be your total surface area. Once you have that total surface area, you know that they're manufacturing the total of 1,572 mailboxes. So you are going to have to figure out how many square meters of aluminum they're going to need. So this is only one mailbox. They're going to have this many more. So you got to multiply that, and then this would be your answer. So that's how you do those problems. Please rewind, watch the video at any point if you need to see how to do these problems. You have an ALEKS assignment, make sure you use the formulas and get that turned in. Thank you.